If fire needs oxygen to burn, how does the sun stay lit in the cold vacuum of space? Today, we reveal the secret power of our star. Imagine you have a small candle burning on your desk. If you take a simple glass jar and flip it over the candle, something predictable happens. The flame starts to flicker, it grows weak, and within seconds, it vanishes. We all know why this happens. Fire needs oxygen. By covering the candle, you cut off its life support. On Earth, this is a universal rule. No oxygen means no fire. But then, we look up at the sky. We see the sun, a colossal ball of fire that has been burning for billions of years in the middle of a cold, dark vacuum. There is no oxygen in space. It is a complete void. So, how is the sun burning? Is it breaking the laws of physics? Or is there something much deeper going on that we often misunderstand? To understand this mystery, we must first look at what fire actually is in our daily lives. On Earth, fire is a chemical reaction. When you burn wood or paper, you are witnessing a process called oxidation. The atoms in the fuel are rearranging themselves. Oxygen atoms from the air are desperately trying to bond with carbon and hydrogen atoms in the wood. When they finally crash into each other and form new bonds, they release energy in the form of heat and light. This is the fire we know. It is a messy, violent chemical struggle that requires a constant supply of air. If you took a giant pile of wood and put it in space, it would never catch fire, no matter how much heat you applied, because there is no oxygen to help those atoms bond. The sun, however, is not a giant bonfire. It is not burning anything in the chemical sense. In fact, if the sun were made of solid coal and had enough oxygen to burn, it would last only a few thousand years before turning into ash. But the sun has been around for 4.5 billion years. This is because the sun uses a completely different source of power. It doesn't rely on chemistry. It relies on nuclear physics. The process is called nuclear fusion, and it is the most powerful force in the known universe. The sun is not a fire. It is a massive, ongoing nuclear explosion held together by its own immense gravity. Everything starts with the sun's incredible size. It is so heavy that its gravity pulls everything toward its center with unimaginable force. Deep inside the core, the pressure is millions of times higher than anything we can experience on Earth. The temperature there reaches about 15 million degrees Celsius. In this extreme environment, atoms behave very differently. Usually, atoms like to keep their distance. Every hydrogen atom has a proton at its center, and since protons are positively charged, they push each other away like the same poles of two magnets. They never want to touch. But inside the sun, the pressure is so crushing and the heat is so intense that these hydrogen atoms are forced to move at incredible speeds. They crash into each other so hard that they overcome their natural repulsion and literally fuse together. When two hydrogen atoms fuse, they create a new, slightly heavier atom called helium. But here is where the magic happens. If you were to weigh the hydrogen atoms before they fused, and then weigh the resulting helium atom, you would notice something strange. The helium atom is actually a tiny bit lighter than the two hydrogen atoms combined. A small amount of matter has simply vanished. Where did it go? It didn't actually disappear, it transformed. It turned into pure energy. This is exactly what Albert Einstein described in his famous equation E equals mc squared. It tells us that even a tiny bit of mass can be converted into a massive amount of energy because it is multiplied by the speed of light squared. This is the secret of the universe. Matter and energy are just two sides of the same coin. In the heart of the sun, matter is constantly dying so that energy can be born. Every single second, the sun fuses about 600 million tons of hydrogen into helium. In that process, about 4 million tons of matter are converted into pure energy. That energy travels from the core of the sun through its thick layers and eventually reaches us as light and heat. To give you an idea of how powerful this is, the energy released from fusing just 1 gram of hydrogen is equivalent to burning 20 tons of coal. This is why the sun doesn't need oxygen. It is building new atoms rather than just rearranging them. It is creating its own light from the very fabric of matter itself. This process of nuclear fusion is what makes stars so special. They are the only places in the universe where conditions are extreme enough to forge new elements. Without this process, the universe would be a dark, cold place with nothing but simple gases. Everything you see around you, including the atoms in your own body, was once created inside the heart of a star through this same process. We are literally made of star stuff. The gold in your jewelry, the oxygen you breathe, and the carbon in your cells were all fused together in the intense heat and pressure of ancient stars that lived and died long before our solar system even existed. Even though the sun is losing 4 million tons of mass every second, you don't need to worry about it running out of fuel anytime soon. The sun is so massive that it has enough hydrogen to keep this nuclear furnace running for another 5 billion years. It is currently in the middle of its life, a stable and reliable source of energy for our planet. Eventually, it will run out of hydrogen and begin fusing heavier elements, changing its size and color. It will expand into a red giant and eventually fade away. But that is a story for the very distant future. For now, we can simply appreciate the fact that we live next to a perfect nuclear reactor that doesn't need a single breath of oxygen to light up our world. So, the next time you see a candle flame or a campfire, remember that you are looking at a simple chemical dance. But when you look up at the sun, you are looking at something far more profound. You are seeing the power of the atoms themselves being unlocked. The sun isn't burning, it is transforming. It is the ultimate proof that in the right conditions, the smallest particles in the universe can create the greatest light. It is a reminder that the laws of nature are much bigger than what we see on our small planet, and that the universe has found a way to shine even in the total silence and emptiness of the vacuum of space. Think about the journey of a single photon of light. It is born in the violent collisions of the core, spends thousands of years fighting its way to the surface, and then travels across the cold void to hit your eye in just 8 minutes. This journey is only possible because the sun doesn't play by the rules of fire. It plays by the rules of the stars. It is a masterpiece of physics, an engine of creation that doesn't require air, only the sheer weight of its own existence and the incredible dance of atoms. We are blessed to be observers of this cosmic fire, a fire that requires no oxygen, yet provides everything we need to survive. It is the heart of our world, the light of our days, and the greatest mystery hiding in plain sight every time we look at the sky.